Ooh, man, I really gotta stop being so bored and actually do something with my life. I can play a game. Yeah, I can play a game. Hey, it's me, MacBook Pro, aka MaxBook Pro. Okay, moving on. Why not make your life more difficult? Go spend hours programming a game you'll play with a computer that you could otherwise play in 30 seconds on a piece of paper with a friend. What's going on, everyone, and welcome to episode number 6 of Everyday Python Projects. Today's project is to build Tic Tac Toe. Without making this overly complicated, we're going to play the entire game within the console. However, if you're feeling up to it, you can use the code I wrote along with the library tkinter to make this with an actual GUI. tkinter, tkinter. I have no clue how you actually pronounce it. Hey, if this was Super Smash Bros., Ness would definitely be trolling us with that TK Thunder. I'm gonna leave now. A GUI means Graphical User Interface, and it's a way to create a visual application for tic-tac-toe, similar to what you might find on a website. But for today's video, we're gonna keep it simple and do everything in the console. Let's do it. Right off the bat, let's visualize the tic-tac-toe board and the possible ways we can win. We can see that a standard tic-tac-toe board is a 3x3 square, and there are 8 possible ways to win the game. 3 across, 3 vertical, and 2 diagonal. To get started, let's import the random library as we're going to need it later in the code and to create our tic-tac-toe board. Next, we need to create our markers, which will be either an X or an O. So let's make a list with an X and an O as the 2 available elements. So we'll create a list of available markers with either an X or an O. Then we'll ask the user to input whether they want to be an X or an O, and we're going to capitalize their response for easier visualization. So let's create the variable yourMarker. It's going to be an input. Do you want to be an X or an O? And let's capitalize this. After this, we'll account for the edge case of the user not picking either an X or an O. We can do this by creating a while statement, while yourMarker not in available markers, which is this list right here. Print, please pick either X or O, ya hooligan. And then we're going to copy and paste this right here so that we stay in this loop until you pick either an X or an O. Whatever you decide to be, the computer will have the opposite marker, and we can account for that like so. If your marker is equal to an X, then computer marker will be equal to O, else computer marker will be equal to X. This says print let's play, select a number between 1 to 9 to fill in the board. And this is an easy way to visualize our board. So let's just see what this looks like. Do you want to be an X or an O? Let's just say X. And you can see here's our 3x3 board, and it's very easy to see that it is an empty board, and we can fill it in like so. Finally, we'll keep track of how many empty spaces are left on the board, the status of the game, meaning is it in progress or did someone win, 2 lists to keep track of the user's moves and the computer's moves, and finally a list of all the winning combinations. So let's create a variable called total empty. This is going to be equal to board.count, and we're going to count the number of underscores. Game status, which for the time being will be in game, and then it lists all your moves, all computer moves, and finally the winning combinations. The winning combinations here are in a list of lists, and this is exactly what we talked about earlier in the video. Right here are all the winning combinations, and we just put that into a list like so. So everything we've done so far sets us up for Tic Tac Toe, but we need to make it into an actual game that has rounds and the ability to pick specific spots on the board to place our marker. We'll keep the game going only if there are empty spots available and if the game status is in game. We can do this easily with the while loop. While total empty is not equal to 0 and game status is equal to in game. Then we're going to create a list that holds the available spaces on the board, as well as a prompt to pick your spot on the board that you want to place your marker. So we can write available spaces, and let's make that an empty list. And then your move will be equal to type integer format and input. Where do you want to place your, we'll put the marker in right here. Pick 1 to 9. And we can format your marker. In case you pick a number less than 1 or greater than 9, we can write these 3 lines of code to prevent the program from breaking. So let's write a comment. Keep the inputs between 1 and 9 to prevent the program from breaking. While your move is less than 1 or your move is greater than 9. First, let's write this print statement. Print a new line, please pick between 1 and 9. And then we're going to copy and paste this whole line of code. Now that we've accounted for picking a number between 1 and 9, we need to see if the space we picked is an empty space. We don't want to place our marker on a space that's already been filled in. So let's write a comment, check if there is an empty space where you want to place your marker. While board your move -1 is not equal to an underscore. Print that space is already filled. Pick another space. And we can copy and paste this once again. The reason we have your move -1 in the variable board is because we're picking a number between 1 and 9. The list board has a total of 9 elements, but the first element in a Python list starts at index 0 and continues on from there. So in this case, the first item is at index 0 and the last element in that list is at index 8. It's easier to think of the tic-tac-toe board like a phone keypad that's numbered from 1 to 9 instead of 0 to 8. So to account for that, we have to subtract 1 from our input to properly place the marker in the correct spot on the board. So if we've satisfied both of these conditions, we can append our move to the list all your moves and put our marker on the board. So let me minimize this first, a little easier to see. So we can write all your moves dot append your move, and we'll also put that on the board as well. So your move -1, like we explained earlier, is equal to your marker. Since this script is set up for the user to make their move first instead of the computer, we'll check after each move if you've won. So check if you won. Then we'll create a for loop for combos in winning combinations. If set combos dot is subset all your moves. Then we'll change the game status to you won. For everyone who took discrete math in college, you're going to love seeing sets again. This is a really neat way to check if any of our inputs so far are winning combinations. So if we look at all of our winning combinations, we can say winning combinations, and here's a list of lists. These are all of our winning combinations. So now if we want to see this in action, let's first put all your moves here, so now it's an empty list. If we append 1, we can see that all your moves is now a list with element 1 in there. And now let's check if any of our moves is a winning combination. Just for this example, we're checking it against the first winning combination right here, index 0, but in the actual code, we'll check it against all combinations. So as expected, this is false because just having 1 isn't a winning combination. However, if we were now to append 2, 3, and 4 to all your moves and then run this again, we now get true. Why is that? Well, let's look at all your moves. And in here we have 1, 2, 3, and 4, and 1, 2, and 3 is indeed a subset of this winning combination list, particularly this right here. So this is a neat way to show if any of our moves so far have granted us a win. Next, we're going to check if we're still in the game. If we won, then there's no reason for the computer to make a move, so we can write a comment, computer's move, if game status is equal to in game. Then we're going to find all of the empty spaces on the board and append it to the list available spaces. So let's write a comment, find available spaces for count, comma thing in enumerate board if thing is equal to an underscore available spaces dot append count. So enumerate keeps track of which loop we're in, and we get that value through count. That way we can find at which index there exists an empty space. If there are available spaces left, meaning the computer nor myself have filled up the entire board, we'll decide where the computer should place its marker. So to check if there are empty spaces, we just have to write if available spaces. Then we'll create a random location. Let's call this random lock. Random.randint between 0 and the length of available spaces minus 1. Using that random number, we will then append our computer marker at the proper place on the board. So board available spaces random lock is equal to computer marker. Finally, we will append this move to the list all computer moves. Alright, so let's summarize. If available spaces isn't empty, then we're going to generate a random number between 0 and 1 minus the length of available spaces. We need to subtract 1 because remember, lists start at index 0. So if we had a list of 4 items, the number of items would start from 0 and end at 3. Index 4 would be out of bounds. Once we find which space is empty, we're going to place the computer's marker in the board using the location of the empty space. Then we append the computer's move to the list all computer moves, and we add 1 because we want to record the computer's moves from 1 to 9, not 0 to 8. I know it's kind of confusing when we write the code, but we have to think about this from the consumer's perspective. Chances are we're probably using this only for ourselves, but in the event that you were to give this to someone else, the code should be constructed such that they can use this without having to modify anything at all. They just execute the code and play the game. Then we're going to see if the computer has won, and we're going to use almost the exact same code that we wrote earlier to see if the user had won. So we can just copy this right here. Now we just need to make a few changes. First, let's write check if the computer won. And then for combos and winning combinations, this is going to be a subset of all computer moves. And then the game status will now be the computer won. With a sad face because we don't want the computer to win. Once the computer has made its move, we're going to calculate the total number of empty spaces and print the board to the console so that we can see what spaces have been filled in. So this will be written outside of the if statement because both myself and the computer have already made their moves. We can write the comment count empty spaces in board. Total empty is equal to board.count. Count all the underscores. And then we're going to print the board, like so, using the same code that we had earlier. Once again, it's a lot easier to print the board like this, where these are the individual rows of the board, and we're printing a few lines in between for easier visualization. Alright, it's the home stretch, 4 more lines of code, and then we're done. So there's 3 outcomes for the game. 1, the user wins. 2, the computer wins. Or 3, it's a tie. No matter what, in all 3 of these outcomes, we'll be kicked out of the while loop because there are no more empty spaces on the grid. However, the status of the game only changes to you won or the computer won if we're able to get outcome 1 or 2. If there are no more empty spaces left, but the status of the game is still in game, then we know that we're at a tie, and that message should be printed out to the console. These 4 lines of code can take care of this right away. We just need to make sure that we wrote this outside of the while loop, since this will happen at the end of the game. So it looks like the while loop starts here, and indeed we are outside of it. So what does this say? If game status is equal to in-game, print it's a tie, else we're going to print out what the game status is. Now we've covered all 3 possible outcomes, and the message to the console is displayed accordingly. The last thing to do is to actually test this out. And let's play through the game. So do you want to be an X or an O? I will select X. Alright, our board is here. Let's play. Select a number between 1 to 9 to fill in the board. And where do you want to place your X? Let's say position 2. And okay, the computer has placed its position at position, or its marker at position 4. So let's say I put this at 5. The computer has placed its marker at position 3, and it looks like we'll win as I'll place this at 8. Alright, it looks like I was able to win, there weren't any hiccups, and the message to the console is correct. There you go, you just made Tic Tac Toe in Python. If you enjoyed the video, make sure to like, comment, and subscribe to my channel, or my laptop will come after you. I will see you in the next one. For the game, similar to what you might find on a website. So